Hi, we're 24751 and welcome to the second episode of FTC 101 programming. In this video, we're going to talk about the electronics of FTC. Before getting into electronic devices though, let's talk about the control system for your FTC robot, which is the layout of all your electronics. There are two ways of setting up your control system, using an expansion hub or using a control hub. A control hub consists of 2 power ports, 4 motor ports, 6 servo ports, 4 USB ports, 2 analog ports, 4 digital ports, 4 I2C ports, and 2 RS485 ports. The motor ports also come with 4 additional encoder ports for motors that come with encoders or external encoders used for odometry ports. Motor ports, encoder ports, and servo ports are pretty self-explanatory. Just connect your motors, servos, and encoders into the corresponding ports and set them up, and they'll be ready to use in your code. Now, analog port can be used to connect with an analog sensor that outputs a range of values rather than a digital which alternate between 1 or 2 states. A common example of an analog sensor is a potentiometer. Meanwhile, a digital port is used to connect with the digital sensors, such as a touch sensor, which only outputs either press or not press state, and digital outputs like digital LED indicators. Sensors like IMU, color sensors, or digital sensors will be connected to the I2C sensor to the I2C ports instead. A control hub notably has 4 USB ports, 2 USB-A ports, 1 USB-B port, and 1 USB-C port. USB-A is primarily used for connecting UVC camera to detect game pieces or scan airport tags, whereas USB-C is used for connecting to a laptop for loading the SDK, but it can also be used for an UVC camera. Finally, the RS485 ports are used for serial communication between ref hubs. You would use this port if you wish to use a secondary ref hub. Now you can also use an expansion hub for your system. While being pretty alike, for the expansion hub to work, an Android phone with a robot controller app is required to connect to the hub, which can be built from your code. Expansion hub is a bit different than control hub. Both have USB-B ports, but the expansion hub doesn't have USB-A and USB-C. On the expansion hub, USB-B is used to connect with the Android phone or update the firmware. On the control hub, it's only used to communicate directly with the I/O system. So basically, you will need to use it at all. Both setup works. However, each will only allow the robot to use 4 motors. Therefore, it is recommended to use both hubs for the best performance. An Android phone won't be needed as the control hub will act as one. You can connect the two together using an SD extension cable and a communication cable, as illustrated. A driver station is required to run the autonomous and teleop program during the match and to set up your electronics when programming the robot. Your robot controller, which can either be the control hub or an Android phone, will provide direct Wi-Fi connection. Connecting to this allows team to use their driver station to run programs and set up your motors and servers. There are 2 ways to set up your driver station. An option is to use your Android phone with the driver station app installed from GitHub. The other option is to use a driver hub. Now the driver hub is effectively an Android phone with built-in USB ports and pre-installed driver station. It is purpose-built for FTC and has several advantages over traditional Android phones. Driver hub charges faster, has a bigger screen, has better case, and it comes with full-size USB ports. However, it is also more expensive, and teams have reported random loss of power, high battery drain during sleep mode, and occasional crashes. So, teams should consider carefully before buying a driver hub.
Now let's talk about motors. They're used to power the drivetrain, intakes, lifts, and other mechanisms, and we mainly use 12-volt DC ones. You can find a list of legal motors in the game manual. Most of the motors have very similar structure, consists of bare motor of 12 volt, gearbox to set the speed and torque, and encoder for precise control. Since bare motors are quite similar, the choice of motor mostly depends on gearboxes, which is the gear ratio, output shaft type, and the ease of mounting. Gearboxes is just a collection of gears and enclosure that connects them. There are two kinds of gearboxes, spur and planetary. Spur gearboxes have spur gears which are stacked on top of each other. Gear reduction is achieved through different size gears on the same plane. It's easy to damage a spur gearbox. From shock load and one gear breaks, the entire gearbox will stop functioning. Planetary gearbox consists of center gear which has smaller gears revolving around it. The outer radius has a ring gear which holds the other gears in place. Planetary gearbox is more efficient than spur gearboxes, and the load capacity is higher too. This is suitable for high-load applications such as drivetrains. Overall, planetary gearboxes are slightly more expensive but more reliable. Planetary gearbox is more efficient than spur gearbox, and load capacity is higher too. This is suitable for high-load applications such as drivetrains. Overall, planetary gearboxes are slightly more expensive but more reliable. Next, we have to talk about servos. Servos are used in FTC for high-low precision applications that are low-load. For example, opening a trapdoor for bolts to fall through. Typically, servos have a limited range of rotation, commonly 180 to 270 degrees. Servos vary widely in price, performance, and value. Fortunately, virtually all servos use a standard 3-wire connector and accept the same kind of controlling signal. There are a lot of servos to pick, so be sure to check out the Game Manual 0 for tips on picking the best one. There are two types of servos: regular servos that can rotate to a given position based on a PWM input signal, and continuous rotation servos, which are technically just small motors. They have no position control. Instead, PWM signal is used to control their rotation speed. Many servos from FTC vendors are dual mode, meaning they can switch between continuous and regular modes. The most prevalent problem with servos is durability, so here are some tips for using one. First, do not backdive servos. Forcibly rotating a powered servo away from its position risks damaging the internal gears. Second, servos break very easily when subjected to lateral loads or bending of the shaft. For example, if you mount an arm or claw directly on the servo without any additional precautions, it's very likely that you will break the servo first time you drive into the wall with the arm extended, and will inevitably happen. And third, use linkages. Instead of mounting some rotating piece directly on a servo, mount it so it can rotate around a pivot. Well, I think that covers most of the important info on electronics in FTC. Again, make sure to check out the Game Manual 0 for more details. Thanks for watching. Stay tuned for the next video. Merry Christmas and Happy New Year, and good luck to all teams.